Every year, billions of dollars evaporate across global industries due to unforeseen project delays, scope creep, and resource misallocation. We meticulously build Gantt charts, assign dependencies, and establish milestones operating under the illusion that a well-documented plan guarantees execution. Yet traditional project management remains fundamentally reactive, relying on human managers to notice when a critical path diverges before they can intervene. By the time a red flag appears on a dashboard, the underlying bottleneck has already consumed valuable time and budget. This reactive posture forces teams into a constant state of firefighting, where mitigating immediate crises takes precedence over strategic foresight. Tasks pile up, dependencies clash, and resource burnout becomes an inevitable byproduct of rigid planning colliding with dynamic reality. The core issue is not a lack of effort or organizational skill, but rather the sheer impossibility of a human mind simultaneously processing thousands of historical data points, team availability metrics, and cross-departmental dependencies in real time. We need a system that anticipates failure before it occurs. The true power of AI in this arena lies in its ability to transform project management from a historical record-keeping exercise into a predictive engine. This shift is driven by machine learning, a subset of artificial intelligence, where algorithms analyze vast amounts of historical data to identify patterns and make decisions with minimal human intervention. By applying these algorithms to project workflows, the software stops merely tracking what has happened and begins to accurately predict what will happen next. Modern platforms ingest years of past project performance, analyzing how long specific tasks actually took compared to their initial estimates. They evaluate individual team member velocity, historical delay patterns, and even external seasonal factors that traditionally disrupt schedules. This is often enhanced by an LLM, or large language model, a type of artificial intelligence trained on massive text data sets to understand and generate human-like language. The LLM can read unstructured data from project comments, emails, and meeting notes to gauge team sentiment and identify hidden risks. When we compare legacy tracking methods to AI-driven predictive timelines, the contrast in utility is stark. A traditional tracker simply alerts a manager that a deadline was missed yesterday. In contrast, predictive analytics will flag a task 3 weeks in advance, calculating a 78.5% probability of delay based on current resource loads and historical completion rates. This proactive intelligence allows leaders to reallocate resources, adjust dependencies, or renegotiate deadlines long before the critical path is ever compromised. We see this predictive capability actively deployed in popular platforms like Asana. Asana utilizes machine learning to continuously monitor the health of a project portfolio, instantly identifying when a specific phase is trending toward a bottleneck. Its algorithms analyze the workload of individual contributors across multiple overlapping projects, automatically detecting when an employee is nearing maximum capacity. Instead of waiting for the employee to report burnout or miss a deliverable, the system proactively suggests task reassignments to balance the load. The efficiency gained from this early bottleneck detection fundamentally changes the return on investment for project management software. When Asana flags a resource constraint early, the cost of mitigation is negligible, often requiring just a few clicks to redistribute tasks. Conversely, resolving that same constraint after a deadline has been breached can incur significant overtime cost, client dissatisfaction, and cascading delays across the entire organizational portfolio. The financial impact of avoiding these cascading failures easily justifies the software investment. Consider the deployment of Monday.com, a high-stakes marketing campaign involving dozens of cross-functional team members. In our testing, we observed how the platform uses predictive analytics to optimize the sequence of creative deliverables. If the data indicates that video editing historically takes 20% longer during the fourth quarter Monday, Com automatically adjusts the projected timeline for all dependent tasks. It ensures that copywriters and social media managers are not left idle waiting for delayed assets. To achieve this level of foresight, teams must properly connect their disparate software tools. This requires API integration, which is a software intermediary that allows two different applications to communicate and share data seamlessly by linking Montcalm with external time tracking software, financial dashboards, and communication channels via API. The predictive engine gains a holistic view of the organization's operational reality. The richer the data ecosystem, the more accurate the resulting forecasts become. However, the effectiveness of any predictive model is entirely dependent on the quality of the information it consumes. A common pitfall organizations face is deploying advanced AI tools on top of fractured, inconsistent data. If team members routinely fail to log their hours, update task statuses, or document scope changes, the AI will generate flawed predictions based on an inaccurate baseline. The algorithms cannot optimize a workflow if the underlying data does not reflect reality. Therefore, the first critical step in exploring AI for project management is establishing rigorous data hygiene protocols. Organizations must enforce standardized naming conventions, consistent state status updates, and centralized communication within the chosen platform. Managers should conduct regular audits to ensure that the data feeding the predictive engine is both accurate and comprehensive. Only when the digital workspace mirrors the physical workflow can the AI accurately map the critical path and identify genuine optimization opportunities. In the realm of software development, Jira has integrated sophisticated AI to manage complex agile sprints. Jira analyzes the historical velocity of a development team, evaluating how many story points they successfully complete per sprint. When a product owner attempts to overload a new sprint with too many features, the predictive engine instantly calculates the probability of failure based on past performance metrics and current code review bottlenecks. This predictive capacity extends to identifying high-risk code deployments by analyzing past bug reports and the specific developers assigned to current tasks. Jira can flag particular features that are statistically more likely to cause integration issues. The platform effectively acts as an automated risk management consultant. Advising engineering leads to allocate more time for testing on specific modules before they ever reach the quality assurance phase. While Asana excels at cross-functional resource balancing, and Montcalm shines in customizable workflow forecasting, Jira provides the most rigorous predictive analytics for technical, sprint-based environments. Choosing the right tool requires matching the AI's specific analytical strengths to the organization's operational methodology. A marketing agency will extract more value from Monday.com predicting asset delivery delays, whereas a software firm requires Jira forecasting code deployment friction. As these platforms evolve, the role of the project manager is undergoing a fundamental transformation. The daily routine of manually chasing status updates, compiling progress reports, and adjusting timeline dates is being entirely automated. Freed from these administrative burdens, a project manager is elevated to a strategic director. Their primary responsibility shifts from tracking past actions to interpreting AI-generated forecasts and making high-level decisions to steer the project around anticipated obstacles. This strategic shift is further accelerated by the introduction of generative AI, a technology that can create new content such as text, code, or images based on the patterns it learned during training. In project management, generative AI is now being used to instantly draft comprehensive project briefs, risk mitigation plans, and stakeholder updates. By analyzing the predictive data, the AI can generate a fully articulated status report that highlights upcoming risks and proposes specific interventions. To maximize the output of these generative features, professionals must master prompt engineering, which is the practice of carefully designing and refining the text instructions given to an AI to produce the most accurate and useful response. Instead of asking a generic question, a project manager might prompt the AI to analyze the last 3 delayed projects and generate a specific risk assessment for the upcoming order. Skillful prompting extracts highly targeted, actionable intelligence from the platform. The compounding effect of predictive analytics and generative reporting results in massive productivity gains. Teams report saving up to 10 hours a week previously lost to manual reporting and schedule adjustment. This reclaimed time translates directly into increased project capacity and higher quality deliverables. The financial metrics clearly indicate that AI-enabled teams operate with lower overhead and a significantly higher rate of on-time, on-budget project completions. Yet there is a distinct danger in over-relying on algorithmic forecasts without applying human intuition. AI lacks contextual understanding of nuanced human dynamics, office politics, or sudden shifts in client sentiment that are not captured in the data. If a manager blindly follows an AI recommendation to reassign a critical task without understanding the interpersonal dynamics of the team, they may inadvertently damage morale or disrupt a fragile collaborative workflow. The algorithms silently power daily operations, but they do not possess leadership. The most successful organizations treat AI as an incredibly powerful advisory tool, not an autonomous decision maker. The machine provides the statistical probability of a delay and suggests a mathematical optimization, but the human manager must weigh that recommendation against qualitative factors. This synthesis of machine precision and human emotional intelligence represents the pinnacle of modern project execution. For teams ready to implement these systems, the most effective approach is a phased rollout. Begin by enabling predictive analytics on a single low-risk project to observe how the AI interprets your specific workflow data. Use this pilot phase to refine data entry habits and calibrate the algorithms. Once the team trusts the forecasts and the data hygiene is verified, you can confidently scale the AI features across the broader portfolio. Ultimately, the true power of AI in this space is not about replacing human oversight, but rather amplifying it by automating the extraction of insights from complex data sets. AI eliminates the blind spots that have historically plagued project execution. It allows organizations to peer around corners, anticipating resource constraints and critical path deviations with mathematical precision. As tools like Asana, Monday.com, and Jira continue to refine their predictive capabilities, the baseline standard for project management will irrevocably change. The competitive advantage will no longer belong to the team that works the hardest to track their tasks. The future belongs to those who leverage artificial intelligence to accurately predict, and then